Hello viewers, I am Kausalya. Today we are going to discuss about response of first order system for unit step input. So what is a first order system? It is a system whose denominator polynomial has the maximum power of 1. For example, this is a first order system. Here you see the maximum power of S is 1. And the type of input is unit step input. How a step input will be? As we already discussed, this is the input whose value varies when t is equal to 0 and it remains constant when the value of t is greater than 0. So this is a step input. Now, the closed loop transfer function of a first order system is given by, this is a simple system. So C of s by R of s is given as 1 divided by 1 plus st. Now, the type of input is unit step input. So, here we will be generally telling the magnitude as a, right? But here unit step input is the value of a becomes 1. So, R of t is equal to 1 and when you take Laplace transform of 1 that becomes 1 by s. Now, we are rearranging this equation. So, C of s is equal to, I am moving this R of s to the right hand side. So, C of s is equal to R of s into 1 divided by 1 plus st. Now, we know what is the value of R of s. It is 1 by s. So, just substitute the values here. So, after substituting from this expression, we are taking the t term outside. So, when you take this term t outside, here it will become 1 by t plus s. Right. Now, I am moving this 1 by t to the denominator, to the numerator part. So, this 1 by t is shifted here and the remaining terms are s into s plus 1 by t. Right. Then we are going to apply partial fraction. So when you apply partial fraction, here this is your expression. So C of s is equal to, I had written that expression. Look carefully, here in the denominator we are having two terms. So for partial fraction we have to introduce another two terms. We can write this expression like this. This is partial fraction. That is a by s plus b by this another term s plus 1 by t. Right, name this as equation number 1. We will use this further. And the next thing is we are going to take LCM here. So when you take LCM, the denominator term will have s into s plus 1 by t. And when you cross multiply, you will be having a into s plus 1 by t and for here b into s. Right. So when you compare this LHS term and RHS term, here these two denominator terms are same. So these two terms will get cancelled. And the remaining term will be having 1 by t is equal to a into s plus 1 by t plus bs. Now, we need to find the value of a and b here. So just for finding the values, when you substitute the value of s equal to minus 1 by t, this minus 1 by t plus 1 by t will cancel each other, right? And the a will become 0. So first thing, I am substituting the value of s equal to minus 1 by t. And when you substitute the values, the a term will get reduced to 0. So remaining term will be 1 by t here as such. And this term reduces to 0. And here in the place of s, I am having minus 1 by t. Right. So here again, these two terms will cancel each other and finally the value of b will be equal to minus 1. And the next thing is to find the value of a. So here just substitute the value of s equal to 0. When you substitute s equal to 0, this whole term reduces to 0 and here the remaining terms will be 1 by t equal to a into, here s is 0. So 0 plus 1 by t, simply 1 by t here. Again, this 1 by t and 1 by t will cancel each other and the value of a will be equal to 1. Right. Now, we are going to substitute the values of a and b in the equation number 1. Right. So, here we are going to substitute the values. So, this is your equation number 1. So, value of a is 1 and b is equal to minus 1. So, just substitute the values here. After substituting the values, we need the output in terms of time, right? Because here we are discussing about time response analysis. So just take inverse Laplace transform. So when you take inverse Laplace transform on both sides, this C of S becomes C of T, and here inverse Laplace of 1 by S is 1, and here this is general formula, that is inverse Laplace of 1 by S plus A. This is given by e power minus A into T, right? So here in the place of A I am having 1 by T. So when you substitute, that will become e to the power minus 1 by T multiplied by this small t. So here I have directly written as minus T by T. So this is our final output response of a first order system for unit step input. And now we are going to draw the graph. For drawing graph, just we are going to substitute the values here. For t, I am going to substitute random values, and finally I am going to draw a graph. So here when t is equal to 0, when you put this t equal to 0, anything to the power 0 becomes 1, right? So here 1 minus 1 becomes 0. So here C of t is equal to 0. And finally when t equal to capital T. So here when you substitute capital T, these two terms will get cancelled, and we will be having 1 minus e to the power minus 1. So when you calculate, you will be having the value of as 0.632. Like that, you just when you substitute the values till infinity, I am having certain range of values as output. So now we are going to draw the graph. So when you look at the graph, this is your input signal. This is a step input signal, right? And it is unit step. The maximum value is 1 here. So here with respect to, that is we are drawing the output response with respect to t and C of t. So here the values of t are respectively 0, t, 2t, 3t, it goes on. And similarly here also we are having the respective values. So when I draw the graph, the output will be like this. So for a unit step input, this is the response of a first order system, right? The video gets over here. Hope you people understand. Thank you.